quite regularly down to the smaller scale projects that we get involved with. So this is for Waters out of South Wales. Worked with them for many, many years now. And they are on a framework with, I think it's Somerset Council. And the scheme they had was to repair a arch bridge in Misterton. So this bridge was originally strengthened back in late 90s, early 2000s. Clearly it was something wasn't done properly because it was racking itself to death again. Very, very shallow cover over a very small arch and quite a heavily used road. I think that if this road's closed, the diversion is quite a long way around. So it was regularly getting battered by 40-ton Arctics, which was not doing it any favours. So main road through Misterton, and you have what is quite a small and a shallow arch. So you're only talking about 500-600 mil high from the soffit of the arch to the bottom of the stream bed, which meant a traditional timbering option wasn't really going to be that suitable. However, the end section there, you can see how it's on a kind of on a skew here. That bit there was done with traditional timbering, which you can see there. Whereas the rest of it, we went with what I think is a one-of-a-kind solution. So I found these things called Geodams, which are effectively a teram, a waterproof teram, that are usually used for stopping, for temporary flood control. So if you get these, you fill them up with water, they make effectively a wall from 0.5 metre high to 1.5 metres high that you can use to prevent floodwaters entrance. So they look a little bit like that. So that is a teram that you just literally just pump water into one end of and it just fills up, and the self weight of it keeps it sitting there and keeps it stable. So I proposed to get one of those and put it inside the arch. The advantage being you haven't got to try and crawl in there and make the timbering. Nobody's got to work underneath it, and it will provide a nice uniform support to the full inside of the arch. And then there's the full sequence of how the works had to be done. So section by section, try and keep the load balanced either side, etc. Do one half of the bridge at a time so they could run plant past the other side and then reinstate everything. Repeat the other way around. So there you can see the timbering in place on the outer side where it has a bit of skew, and then you can see there the geodam sitting inside the arch. It's very difficult to get a picture of because of the constraints, but you can see it there inside the arch, filled up with water, and that's putting a pressure against inside of the wall, inside of the arch, and keeping it stable. And there's the back of the arch exposed, so it wasn't in the best of condition, and you can see the road's only 300 mil above the outside of the arch here, the crown of this at its shallowest point, which is not a great deal for quite a slender arch. And there you can see when it's all being pointed up by the guys from Waters, did a nice tidy job. And then all the road construction was built back in, compacted. Away you go, and now you can go on Google Maps. This was done in November 21, and you can see there the fully reinstated road is back in place and hopefully fit for more than 10 years. But we'll see on that front. I would hope so. But you couldn't even see there was really an arch bridge there. And unfortunately, this arch bridge was listed, so that the cheapest option would have been to have ripped it out and replaced it with a modern alternative. But it was listed and protected by English heritage, so we had to reinstate it and try and maintain as much of it as we could, which is what drove the whole methodology.